today's section is 6-7 inverse relations and functions. Our three objectives: find the inverse of a relation or a function, find the domain and range of a relation and its inverse, and to graph a relation and its inverse. So just a refresher, a relation is a function when each input has exactly one output. Okay? Every input has exactly one output. So if a relation interchanges the first and second coordinates of each ordered pair, we obtain a relation that is the inverse of the original relation. So if AB is an ordered pair of a relation, then BA, switching the x and the y coordinate, is an ordered pair of its inverse. If both a relation and its inverse happen to be functions, they are 1, 2, 1 functions. Okay, so let's start off by kind of seeing what it would look like. So what are the graphs of t and its inverse? So the relation of t, so my relation is made up of 4 ordered pairs. So if I plot it, 0, -5, 1, 2, 3, 4, 5 is right there. 1, -4 is right there. 2, -3, and 3, -3. So it looks like that. So the first question is the relation a function? So does each input have exactly one output? So in this case, yes, it is a function because each input has exactly one output. Oops. Okay, so what that means is 0 is the input and it has one output, -5. 1 is an input and it has one output, -4. 2 is an input and it has exactly one output. 3 is an input and it has one output. Even though it's the same as 2, each input has only one output. Okay, now the inverse. I want to graph the inverse. So what's going to happen is all I'm going to do is switch the x and y values. So that means it's going to be -5, 0, -4, 1, -3, 2, and -3, 3. So -5, 0, 1, 2, 3, 4, 5, -4, 1, -3, 2, -3, 3. So that would be the inverse. So the question now is the inverse a function? So it would be no, because one input, and I'm referring to -3, has more than one output. Okay, so if you think about it as an input-output, -5 has one output of 0, -4 has one output of 1. However, -3 has more than one output. -3 has 2 outputs, so therefore it is not a function. Okay, the graphs of a relation and its inverse are the reflections of each other in the line y equals x. So the line y equals x is just at the origin with a slope of 1. So they are just reflected over this line. So you learned this in geometry. Whenever you reflect over the line y equals x, we're just switching the x and the y values. Okay, so that would be our introduction there. Domain. So the domain of my relation is the set of all input values. So in this case, it's a scatter plot. So instead of being all real numbers, my domain is just 4 values, 0, 1, 2, and 3. And the range is the set of all my y values, -3, -4, and -5. Now, the domain of the inverse, if you take a look, I'm just going to draw an arrow. There's my domain, there's my range. So the domain is -3, -4, and -5. And the range is going to be 0, 1, 2, and 3. Oops. Now what you should be noticing is the domain became the range and the range became the domain. And that should make sense because what happens here is if we switch the x and the y values, we're switching the domain and the range of each other. Okay, so moving on, next page. If you describe a relation or function by an equation in x and y, you can switch x and y to get an equation for the inverse function. So we use this notation. It looks like f to the negative 1 power of x, and that is our inverse notation. Okay, so if I want to find the inverse, we're going to switch x and y and solve for y. Okay, now one thing to keep in mind, f of x is the same thing as y. So this is the same thing as writing y equals 2x plus 8. Okay, so if I want to find the inverse function, I'm going to switch x and the y. So I have x equals 2y plus 8. That would be step number 1. Step number 2, I want to get the y by itself. So I subtract the 8 to the other side. I have x minus 8 equals 2y. And then the last step is to divide by 2. Okay, so I have two choices on how to write this. The inverse function, f inverse, is going to be x minus 8 all over 2. Or it's the same thing as 1/2 x minus 4. Because again, if I just take the 1x and split it apart, that's how I would get it. Okay? In general, the domain of the original equation ends up becoming the range of the inverse. And then the range of the original function is going to become the domain of my inverse function. Okay, so first question, is the original equation a function? Well, the original equation is a line, and it has a slope of 2 and a y-intercept of 8. So it's going to do something like that, where it's a really steep line. So notice that it goes left forever, it goes right forever. It doesn't have any red flags. Red flags meaning zero denominator or negative radicals. So is the original equation a function? Yes. Okay. Is the inverse a function? Well, notice that the inverse is also a line. So therefore the answer is yes, it is a function. Every input has exactly one output. Okay. Now we have another test here. How to determine a function versus not a function. We have something called the vertical line test. Okay, so if a relation passes the vertical line test, then the relation is a function. So what that means is this: if I can draw a vertical line and it does not go through more than one point, it is a function. So the line we just talked about in the previous part here. I can draw a vertical line anywhere I want, and it will never go through more than one point on that line. So therefore, this will pass the vertical line test. Okay? The horizontal line test is the same concept. The horizontal line test says that if a relation passes the horizontal line test, then the inverse of that relation is going to be a function. So again, if I take that line that I was considering, if I draw a horizontal line and it does not go through more than one point, that means that the inverse of that, not vertical, the inverse will be a function. Okay? So, symbol to represent the inverse. Again, it looks like f to the negative 1 power, but that's f inverse, or the inverse of f. The notation f of x is used for functions, but the relation f inverse may not even be a function. Okay, so be aware that your textbook could use f inverse without using the x, but this is the standard writing that we're going to use. Okay, so that's f of x. Be careful if you've dealt with negative exponents before. We take the reciprocal, but f inverse does not mean f to the negative 1 power. So the f is not a variable, f just means function. Okay, so let's turn the page. Okay, what are the graphs of x squared minus 1 and its inverse? So I'm going to use vertex form. So using vertex form, I have 1, x minus 0 quantity squared, and then minus 1. So my vertex is located at 0, negative 1. Okay, so 0, negative 1 puts me right there. Vertex is at 0, negative 1. Now, I can go to the left and the right. I can do the 1A, 3A, 5A, or I can make a table of values. It doesn't matter. So let's just say I use the table of values. So if I go to the right of 0, I go 1, 2, and 3. So what happens here is I have 1 squared minus 1, which is 0. I have 2 squared minus 1, which is 4 minus 1, 3. And then I have 3 squared minus 1, which is going to be 8. So if I go to 1, 0, 2, 3, and 3, 8, 4, 5, 6, 7, 8. Okay, that's the right side of my parabola. And notice that fits the 1A, 5A, 1A, 3A, 5A as well. Okay, if I mirror it to the other side, 1, 2, and 3, there's the other side of my parabola. Okay, my domain, my graph goes left and right forever, my parabola, so it is all real numbers. My range, it has a minimum, so that means it's going to go from negative 1 all the way up to infinity. Graph the inverse. So now I'm going to do the inverse, and I'll use a different color by switching the x and the y values. So what that means, instead of 0, negative 1, I'm going to be at negative 1, 0. Okay, instead of 1, 0, I'll be at 0, 1. Instead of 2, 3, I'll be at 3, 2. 1, 2, 3, 1, 2. Instead of 3, 8, I'll be at 8, 3. So there. So what you'll notice is this is the first half of the parabola like that. Okay. In order to get the second half of the parabola, I'm going to use a different color just so you can kind of see it in a moment. It's going to be down here, it's going to be down here, and it's going to be down here. So that's just taking the ordered pair and then switching the x and y coordinates. So what you'll notice is, if your function is a quadratic parabola, the inverse is going to be a sidewards one like that. And then if it's down, it's going to end up facing the other way like that. Okay, domain and range. So again, the domain ends up becoming the range of the inverse. Okay, it'll go up and down forever. However, if you look at my graph, the farthest left x value is negative 1, and it goes right forever. So that's why my domain is all x values greater than negative 1, as opposed to the y values. Okay, letter B, find f inverse. So what I'm going to do is I'm going to switch my x and my y value, like that. Okay, now, in order to solve this, I'm going to add 1 to the other side. So I have y squared equals x plus 1. So here's the key, and this is why I did it in 2 colors. If you want to undo a square, you have to square root. So what most people will do is they'll have the x plus 1 under the square root. This by itself is the green half that you see. Sometimes people are going to forget that when you undo a square, you need to have the plus or minus. So the plus side is what creates the green half. When you do the negative, that's how you get the red half of your graph as well. So that's how you get the 2 halves of your parabola. You have to have the plus or minus sign. So f inverse equals plus or minus the square root of x plus 1. Okay. 1c, is the inverse of y a function? So there's 2 ways to talk about this. I can talk about f inverse is not a function because if it's like this, f inverse fails the vertical line test. So vertical line test, I draw it, it goes through more than 1 point. So that means that this is not a function. Option number 2, f of x, the original parent function, fails the horizontal line test. So when you give the horizontal line test and it fails, that means that the inverse of this is not a function. Okay, so those are two different options you can use. In a moment, we're going to pause here and we're going to try example 2 and 3. Okay, so consider the domain and range. What are the domain? What's the range? And then what is the inverse function? Okay, so pause here, give it a try. Let's see how we do. Okay, let's start off with number 2. A, what is the domain and range of f? So what you'll notice here is that it can't be all real numbers because it's a line. I'm sorry, it's not a line. This is a square root function. So we talked about square root function. In order to find the domain, you have to take what's inside of the radical, so the x minus 2, and you have to set it greater than or equal to 0. So once I am here, I'm going to add the 2 to the other side, so I have x is greater than or equal to 2. So that is my domain. The domain is going to be from 2 to infinity. Okay? When x is 2, y is 0. When x is 3, y is 1. When x is 11, y is 3. What's happening here is you're only getting half of this parabola. Okay? That means that for the range, it is the smallest y value, which is 0, and it keeps going up forever, so to infinity. What is the domain and range of the inverse? So the domain becomes the range. So the range is going to be from 2 to infinity. And the domain is, the range becomes the domain. So that would be from 0 to infinity. Okay, what is f inverse? I'm going to switch the x and the y values. In order to get rid of the square root, I have to square. And then to get the y by itself, I add the 2 to the other side. X squared plus 2. Okay, so what that means is f inverse of x equals x squared plus 2. What you might be thinking to yourself is, how can the inverse of half a parabola, which is right here, give me the inverse that's a full parabola? Keep in mind that the domain of this is only from 0 to infinity. That means you only want the right side of this parabola. So the inverse of half a parabola is still half a parabola. Okay, is the inverse a function? So the answer would be yes. And the reason why, you can see each input has exactly one output. Okay, or you could say f of x passes the horizontal line test, or you can say the inverse passes the vertical line test. Any of those will work as an answer. Okay. Number 3, consider the function. So for number 3, this is just a line and it has a negative slope. So because it's a line with a negative slope like that, what's the domain and range? Well, if it's a line, the domain is all real numbers and the range is also all real numbers. It goes up and down, left and right forever. The inverse of a line is still going to be a line. Domain and range, when you switch them, still the same. What is the f inverse? X equals 6 minus 4y. I'm going to subtract the 6 to the other side. And I'm going to divide by negative 4. Okay, so again, two choices. You could have x minus 6 over negative 4. Okay, or you could have negative 1/4 x plus 3/2. Because again, the negative 1 over 4 and then negative 6 over negative 4 becomes a plus. Okay, is f of x a function? Okay, and yes, it is. Again, same 3 reasons. Any of those 3 will work. Okay. Composition of inverse functions. So almost done here. If f and f inverse are inverse functions, then for x in the domains, what happens here is this. What they're just trying to say is, if you put the inverse into the regular function, okay, so that's this one, put the inverse into regular, or if you put the regular into inverse, what's going to happen is everything's going to be cancel out, and the only thing remaining is you're going to be left with x. That's all that means. Okay, so f of x equals 2x plus 4. First thing I'm going to do is find the inverse. X equals 2y plus 4. I subtract the 4 to the other side, and then I divide by 2. So this is 1/2 x minus 2. So that's f inverse. Okay, f of f inverse of 1. So if I find f inverse of 1 first, what that means is I'm going to take this 1 and I'm going to put it in right there. So I have 1/2 of 1 minus 2. So 1/2 minus 2 is negative 3/2, right? If I have 50 cents and I spend $2, I still have $1.50 left. Now I want to find f of negative 3/2. So I'm going to put that into function f right there. So 2 times negative 3/2 plus 4. Okay, the 2's are going to cancel out. I'm left with negative 3 plus 4, which leaves me with 1. So f of f inverse of 1 is 1. What I put in, I get right back out. And then same thing, if I do f of 1 first, which is right there, that's 2 times 1 plus 4. So that would give me 6. If I do f inverse of 6, that would be 1/2 of 6 minus 2. That's 3 minus 2, which takes me right back to 1 again. When I put in 1, I get out 1. When I put in x, I get out x, whatever you put in there. Okay, for g of x, okay, g inverse, x equals 4 over y plus 2. I multiply the y plus 2 to the other side. I divide by 4. I'm sorry, I do not divide by 4. I divide by x. So I get 4 over x. And then the last thing I do is subtract the 2. So y equals 4 over x minus 2. Okay, I do g inverse of 0. So g inverse of 0, I am left with 4 over 0 minus 2. Okay, and then this is undefined. So because it's undefined, I can't do anything there. When I do g of 0, I have 4 over 0 plus 2, so that's 4 over 2, which is 2. I do g inverse of 2, so that's 4 over 2 minus 2. So that's 2 minus 2, which takes me right back to 0 again. So I'll put in 0, get out 0. Okay. Be careful when finding an inverse. You normally switch the variables. In real-life applications, the dependence of variables is fixed, and their order should not be switched. Okay, so just be careful on those things there. Okay, so that is our inverse functions. Hopefully you understand. Switch x and y and solve for y. Switch the domain, switch the range, switch the x's and y's when you're trying to graph as well. Okay, so that is 6.7.